Students, welcome to the sixth session of our first module in compressible fluid flow. So students, in the previous session, we have learned a very important equation called adiabatic steady flow energy equation, where you can write a square by gamma minus 1, where a is sound velocity, plus v square by 2 can be written as v max square by 2, right? Vmax square by 2 means where Vmax is the maximum velocity that can be obtained in the flow by extracting the thermal energy, right? So Vmax square by 2 is also equal to what? A0 square by gamma minus 1, where A0 is stagnation, this velocity of sound in the stagnation state, right? Stagnation state. Also, this is also equal to what? Gamma plus 1 by 2 gamma minus 1 a star square, right? A star square, where a star is the velocity of sound in the critical section. Critical section is the section where velocity of field velocity or velocity of flow is equal to velocity of sound, is equal to a constant. So this is the equation we have derived in the previous session. This is the general form of adiabatic steady flow energy equation, incorporating three different speeds: A0, A star, V max. Okay. So we are trying to develop a relation or an expression relating all the three different reference velocities like A0, V max, and A star square. Now I will be deriving an equation separately for all these three different velocities. Okay, so you just keep this equation with you when it has 1. Okay, so constant, keep it as 1, equation 1. So we'll be using this equation often while proceeding to the next sections. Okay, so students, critical speed of sound. What is critical speed of sound? Critical speed of sound means speed of sound in the critical section, that is A star. That is A star. So we are deriving an equation for A star. So what was the expression relating A star and A star with the other V and A? You can write it as V square by 2 plus A square by gamma minus 1 equal to gamma plus 1 by 2 gamma minus 1 into A star square, right? So I'll be grouping all other terms together in one side and uh, letting A star be alone in another side. So how will you do that? So A star square equal to, I'm taking all the other terms to other side and rearranging it, and you will get 2A square plus V square gamma minus 1 by gamma plus 1, right? So this is the equation relating A star square. How did you get that? I will explain this once more. I'm taking this term to the other side, or before that I will rearrange it like this: gamma minus 1 V square plus 2A square by 2 gamma minus 1, right? So I'm taking the LCM and multiplying it. So we will get this, and is equal to gamma plus 1 by 2 gamma minus 1 A star square, right? So this 2 gamma minus 1 and 2 gamma minus 1 cancels. Then taking this gamma 1 plus gamma plus 1 to the LHS, we will get You will get what? A star square equal to 2a square plus e square gamma minus 1 by gamma plus 1. So keep this equation as 2. Okay. So from equation 1, you can also write a0 square by gamma minus 1 equal to gamma plus 1 by 2 gamma minus 1 a star square. Right? This is a0 square. Okay. Okay. So we need, if you want to write a star square in terms of a0 square, what is required? What do you have to do? You just have to take this term to this side, right? You will get a star square equal to 2 gamma minus 1 by gamma minus 1 into s into gamma plus 1 into a0 square. So gamma minus 1 gamma minus cancel. So you will get a star square equal to 2 gamma plus 1 by a0 square. This is equation 3. So you have got a star in terms of you have got two type of expression. What are they? First one is this one, a star in terms of a0. Another is a star in terms of a and b. So critical value of speed of sound is written in two different forms. Okay. Now again I can write a star square equal to 2 gamma plus 1 a0 square, right? A0 square can be written as, how can you write a0 square? Gamma rt. Root gamma rt is that gamma rt 0. Root gamma rt 0 is a0. So a0 square is gamma rt 0. Right? So this is another form of a star square. Okay. Now you have to how to write stagnation speed of sound in stagnation speed of sound. Stagnation speed of sound. A0, right? A0. Now we have to derive expressions for A0 in terms of other velocities. So a square by gamma minus 1 plus v square by 2 equal to a0 square by gamma minus 1, right? So a0 square can be written as a square by gamma minus 1 plus v square by 2 into gamma minus 1. So it will be a square plus gamma minus 1 by 2 v square a0 square. So this is one equation for a0 in terms of a and v. Now if you want to write a0 in terms of a star square, a0 square by gamma minus 1 is nothing but gamma plus 1 by 2 gamma minus 1 into a star square, right? So this gamma minus 1 and gamma minus 1 cancel. A0 square can be written as gamma plus 1 by 2 a star square. So this is A0 in terms of a star. Stagnation speed of sound in terms of critical speed of sound. Similarly, A0 square by gamma minus 1 can be written as V max square by 2. So A0 square can be written as gamma minus 1 by 2 V max square. Right? This is A0 in terms of V max, maximum velocity. Now we will derive expression for maximum isentropic speed or Vmax. How Vmax is obtained? When the gas expands, its local temperature decreases, and expansion taking place means pressure decreases, velocity increases. When gas reaches the minimum possible temperature, maximum expansion is done and the velocity will reach maximum. That particular velocity is known as V maximum. We have already written the expression. So V max square by 2 is nothing but V square by 2 plus A square by gamma minus 1. So V max square can be written as V square plus 2 by gamma minus 1 A square. Right? Also we can write it as V max square equal to V max square by 2 equal to 2 gamma, sorry, gamma plus 1 by 2 gamma minus 1 A star square. Right? So V max square can be written as gamma plus 1 by gamma minus 1 A star square. So these are the different expressions relating Vmax with other velocities. Now I will introduce another reference term called reference Mach number, a dimensionless parameter, reference Mach number. So students, you know Mach number. What is Mach number? Mach number, the reference Mach number is known as m star, okay, m star. So you know a Mach number is V by A, velocity of flow by velocity of sound, the local velocity of sound. Okay. So what will be m star? M star is defined as velocity, local velocity, local fluid velocity with ratio of local fluid velocity to the critical sound velocity, critical V by A star. So students, in the case of Mach number varies with when velocity increases, Mach number increases. When sound velocity decreases, Mach number decreases. So Mach number is a function of both V and A. So since both V and A are variables, Mach varies with respect to both the parameters, right? So students, there are many disadvantages for it has got mainly two disadvantages in case of Mach number. What are they? First one is that it is not proportional to the velocity alone. Mach is not proportional to velocity alone. Mach is inversely proportional to A also, right? Right. The second being the magnitude of Mach at very high velocities. So when the velocities become very high, students, when velocity is very high, naturally what happens to Mach number? Mach number increases. But students, you have to note that when velocity becomes very high, temperature decreases to very low values, because expansion is taking place. Expansion means loss of heat, it is accompanied by decrease in temperature. So temperature decreases to very low values. Hence, if temperature decreases, root of gamma RT decreases. It means velocity of sound decreases. So at very high velocities, V very high means A very low. So Mach will tend to infinity at such cases. So it is very difficult to use Mach at when Mach approaches infinity, means it won't be that useful in calculation and all. So that is why I have introduced it is introduced another term called reference Mach number, where V by Mach reference is nothing but m star is nothing but V by A star. So here students, whenever if at all the velocity is increasing to very high value, A star remains constant, because A star is a constant value. It is the speed of sound at critical section. It doesn't vary with expansion or compression or any and it doesn't vary with temperature. It is a constant value. So Mach star is useful in certain cases due to that advantage over the simple Mach number. Okay. So students, Mach reference star can be, or Mach star square equal to what? V square by A star square, right? So it can be written as V square by A square into A square by A star square, right? So it can be written as, what is this? Max square into gamma RT, right? By X square is gamma RT. S star square is gamma RT star, right? So gamma R and gamma R cancel, equal to M square T by T star, right? Right? So students, M star square equal to M square into T by T star. So students, T by T star is nothing but T by T0 into T0 by T star, right? So students, you have already learned T0 by T, relation of T0 and T as 1 plus gamma minus 1 by 2 max square, right? You have already learned the relationship between stagnation properties, stagnation temperature and local temperature, static temperature, right? So T0 by T star, T0 by T is 1 plus gamma minus 1 by 2 max star, right? So T0 by T star can be, so T0 by T is, see, T0 by T star can be written as T0 by T at Mach equal to 1, right? Because T star is nothing but critical section. T corresponding to critical section. At critical section, Mach equal to 1. So here we put Mach as 1. So it will be 1 plus gamma minus 1 by 2. 1 plus gamma minus 1 by 2 means gamma plus 1 by 2. Gamma plus 1 by 2. Right? So here you can substitute gamma plus 1 by 2. Plus Mach star square is nothing but Mach square into T by T0 into T0 by T star, right? So T by T0 is nothing but T0 by T, you know. T0 by T is 1 plus gamma minus 1 by 2, right? T0 by T is 1 plus gamma minus 1 by 2 m square, right? So T by T0 is inverse of that. So it will be 1 plus gamma minus 1 by 2 max square. T0 by T star is nothing but gamma plus 1 by 2, right? Now I am taking this term to left hand side. What will happen? Max star square into 1 plus gamma minus 1 by 2 max square equal to gamma plus 1 by 2 into max square. Okay, now I open the bracket, max star square plus gamma minus 1 by 2 max square into max star square equal to gamma plus 1 by 2 max square, right? So I'm taking this to left hand side. I'll do one thing. So this will be minus equal to 0, right? So grouping the max square terms together, do one thing. Max square term plus max star square plus max square into gamma minus 1 by gamma minus 1 by 2 max star square minus gamma plus 1 by 2 is equal to 0. I have taken max square outside of that bracket. From this 2, I have taken max square outside. Okay. Now I will write this it as max star square equal to max square. I've taken to the other side again, and the sign changes. Gamma plus 1 by 2 minus gamma minus 1 by 2 max star square, right? So max square is equal to max star square by gamma plus 1 by 2 minus gamma minus 1 by 2 max star square. Okay. Now I will I'm going to divide the numerator and denominator by, okay. Okay, I will divide numerator and denominator by 2 by gamma plus 1. Okay, divide by 2 by gamma plus 1 in both the numerator and denominator. 2 by gamma plus 1, 2 by gamma plus 1. So what will happen? Max square equal to max star square 2 by gamma plus 1. Sorry, not dividing, I am multiplying it with it. Not dividing, multiply. Okay, better to multiply. Multiply by 2 by on numerator, both the numerator and denominator. So that's what happened. 2 by gamma plus 1 m star square by 1 minus gamma minus 1 by gamma plus 1 m star square. Okay, so this is the relation between Mach and max star square. Mach and max star square. So it is evident from this equation that if m is equal to 0, that is Mach equal to 0, then what will be max star square? Max star will also be equal to 0. So when m equal to 1, m star is also equal to 1. So as m approaches infinity, students, if the value of, if note it that m equal to 0 means m star is also equal to 0 from this equation. M equal to 1 means m star should also be equal to 1, right? M have to be 1 means here in numerator it should be 1, denominator also should be 1, then only this all cancels and get equal to 1. So if you put m star equal to 1, m will be also equal to 1. You just check it on your own. If you substitute a value of m star as 1, you will get m as also equal to 1. So whenever m equal to 0, m star is also equal to 0. M equal to 1, m star also is equal to 1. But students, when you substitute when m approaches infinity, m star won't approaches to m star will never approach to infinity. Why? Because if you, it will always, you just substitute, you just try to substitute m star m sub, if m approaches infinity, it means the denominator should be equal to 0, right? Denominator should be equal to 0. What is the denominator? 1 minus gamma plus 1 by gamma minus 1 m star square should be equal to 0, means 1 equal to gamma plus 1 by gamma minus 1 m star square, or m star square equal to gamma minus, this should be minus, this should be plus, right? So m star will be gamma plus 1 by gamma minus 1, right? So m star will be root of gamma plus 1 by gamma minus 1. So students, when m equal to infinity, m star will be some value around. So students, you can note that this value will never be equal to infinity. So this is a finite value. This is a finite value. Why? Because if you substitute gamma equal to 1.4, so 1.4 plus 1 by 1.4 minus 1, if you take the square root, you will get a finite value only. It never approaches to an infinite value. So that is the advantage of using Mach star. So whenever in any case, in wherever the case is the Mach number is approaching infinity, means if you use m star instead of Mach, you won't be encountering such problems of reaching or approaching infinite values in the case of Mach star, reference Mach number. So that is the advantage of using m star as a reference number. Okay. So another dimensionless velocity or dimensionless parameter used is v by a0, velocity by a0. So earlier reference Mach number was v by a star. This is another dimensional velocity v by a0. V by a0 can be written v by a star into a star by a0. What is v by a star? It is Mach star. A star by a0. Right? So substituting v by a0 square. So you have already got the relationship between a star and a0, and so a star and a0, and Mach star and Mach. So from where will you get a star by a0? So turn back your you already think a star and a0. Okay, this is equation number 3 is a relationship between. So a star square by a0 square is nothing but 2 by gamma plus 1, right? Right, and another relation is m star square can be written as m square into. So this is another relation that can be used for m star square. So substituting all these relation in this particular expression, you can write v by a0 so for v by a0 square. So if you square this m star square, so instead for m star square you can write it as gamma plus 1 by 2 into 1 plus gamma minus 1 by 2 Mach square into Mach square, right? So this is the substitution for m star square, v by a0 square into a star by a0 whole square is nothing but 2 by gamma plus 1, right? So we can cancel this gamma plus 1 and gamma plus 1 here, 2 and 2. What is remaining? Remaining v by a0 square equal to some Mach square by 1 plus gamma minus 1 by 2 Mach square, or v by a0 is equal to m by 1 plus gamma minus 1 by 2 Mach square root. Right? So this is the relationship between the dimensionless velocity v by a0, local velocity of sound to the stagnation speed of local velocity of field by stagnation speed of sound. So now I will introduce another term called Crocco number. Crocco number. So Crocco number is another dimensionless velocity Cr equal to V by, instead of A or A0 A star, we use Vmax. V by Vmax. So V by Vmax can be written as V by V star into V star by, instead of V star you can use A star. A star into A star by Vmax, right? So V by S star is nothing but reference Mach number or M star into S star by V max. Similarly, here also Clock number square. CR square is nothing but M star square into S star by V max square. So M star square equation we know. What is equation? Max square into gamma plus 1 by 2 1 plus gamma minus 1 by 2 max square into S star square by V max can be written in terms how think here V max square equal to V max square by S star square equal to gamma plus 1 by gamma minus 1. Gamma minus 1 by gamma plus 1. Right. So this gamma plus 1 cancels. Finally, Croc square equal to, Croc equal to some Mach by 2 by gamma minus 1 2 by gamma minus 1 into 1 plus gamma minus 1 by 2 max square whole root. So this is the equation for Croc in terms of Mach number. Croc number in terms of Mach number. We are now going to learn a new concept called impulse function. Impulse function. What is impulse function? Have you heard of impulse function? Impulse function is nothing but that force term, right? Impulse function is a force term. So for the momentum equation, I already learned. Actually, the Euler's equation we are derived dp by rho v dv plus g dz equal to some 0. This equation you have already learned, Euler's equation, while deriving the conservation of momentum equation. So if you consider dz as 0, if dz equal to 0, means what? Means what? You can write it as dp plus rho v dv is equal to 0, right? So this is a differential form. If you write it in algebraic or after integration, you can write it as some and consider and if you incorporate the area term, you can write it as PA plus rho AV square equal to constant. Instead of 0, while you integrate, the 0 will become constant, and we have added the area term also. So P by rho V square is equal to constant. Actually, P by rho V square is equal to constant. Now PA plus rho AV square is equal to constant. So this is the momentum equation for one steady one-dimensional flow. Momentum equation for steady 1D flow, right? PA plus rho AV square equal to constant. What is PA? Pressure term. So rho AV square is nothing but momentum term. So sum of pressure force term and momentum term at any section is constant. So that is the idea of momentum equation. So students, I am introducing a term called F. F is nothing but impulse function. Impulse function. The impulse function F is nothing but sum of pressure force and momentum force or inertia force. So this is pressure force, and this is inertia force. Sum of pressure force term and inertia force term is known as impulse function, right? So I'm having a section, a flow section. Let it be a tube or some pipe. So some mass transfer is taking place. Flow of fluid is taking place. At the inlet section, pressure is V1, density is ρ1, velocity is V1, area is A1, and outside and exit point P2, ρ2, V2, A2. So here F1 can be written as how P1 A1 plus ρ1 A1 V1 square, right? Similarly at exit, so if this impulse function at entry inlet is F1, impulse function is at the exit is F2. So F2 can be written as P2 A2 plus ρ2 A2 V2 square. So students, the net force, F net is nothing but thrust produced by stream of flow. Thrust produced by the stream of flow, by the stream or the flow that is taking place between stream of flow between two sections, or it is also known as stream thrust. So stream thrust is nothing but F net can be calculated by the difference, calculating the difference between impulse function at both section, F2 minus F1. So what is F2? P2 A2 plus ρ2 A2 V2 square minus P1 A1 plus ρ1 A1 V1 square, right? So this is nothing but stream thrust, or thrust produced by stream due to the flow between two sections. So it is nothing but the difference between impulse function at two different sections. The students, for a perfect gas, you can write rho as P by RT, right? So ρ2 is equal to P2 by RT2, right? Okay, you just keep it as rho equal to P by RT. Now impulse function F can be written as PA plus rho AV square, right? So PA plus P by RT AV square, right? So if I am multiplying with the gamma in numerator, both in numerator and denominator, what will be gamma RT? A square, right? So it will become F equal to PA plus gamma PAV square by A square, right? So what is V square? V square by A square? PA plus gamma PA M square, max square. I'm taking PA as common, 1 plus gamma M square. So inverse force is nothing but PA into 1 plus gamma M square. Students, F is nothing but pressure force PA into 1 plus gamma M square. So for sake of study, I am introducing a non-dimensional impulse function F by F star. F by F star is nothing but PA 1 plus gamma M square by P star A star 1 plus gamma M square. So at M at critical section is nothing but 1. So 1 plus gamma. M star is equal M at critical section is 1 at the critical section, right? So this is a dimensionless impulse function. So students, now we are going to learn another topic called effect of compressibility. Effect of compressibility. Compressibility on dynamic pressure. Dynamic pressure. So before that, what do you mean by compressibility? Compressibility is the property by which a fluid can change its density, or density, the 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 property which allows the density of the fluid to change. So density remains is not equal to constant. That property refers compressibility. Compressibility, right? So what is dynamic pressure? Dynamic pressure. So students, dynamic pressure in case of incompressible flow. You know the momentum equation for incompressible steady inviscid flow. What was that equation? Bernoulli's equation. Bernoulli's equation is valid only for incompressible steady incompressible inviscid flow. The shear stress is body force and shear force are neglected. That is why we are derived Bernoulli's equation for Euler's equation. So this equation is nothing but P by rho plus V square by 2 equal to constant for same Z. So when Z1 is equal to Z2, you can write P by rho plus V square by 2 is equal to constant. So students, it means since rho is constant, you can take it as uh, half rho V square equal to constant, because rho is equal to constant in case of incompressible flow. Since this is incompressible, rho can be taken to the constant side also. So P plus rho V square is equal to constant, right, at any section. So I am writing, if in this equation the constant obtained in the total pressure is the total or stagnation pressure. Since the total pressure is obtained by isentropically decelerating the flow to zero velocity. So if I am decelerating this this flow flow isentropically to zero velocity, if say velocity tends to zero, means P reaches max. That particular velocity tends to is zero isentropically. P reaches its maximum value, and that value is nothing but stagnation pressure or total pressure. So this equation become P is the constant the P plus half rho V square is equal to P0. It can be also written as P plus half rho V square is equal to P0, right? So this P0 is stagnation pressure. The same is the concept we have used in the stagnation enthalpy. H plus half V square is equal to H0. Similarly, P plus half rho V square equal to P0. So students, I am introducing a term called dynamic pressure. Dynamic pressure is nothing but P0 minus P. Dynamic pressure is denoted by Q. So in case of incompressible, Q incompressible, P0 minus P is nothing is termed as dynamic pressure. Or you just Q is nothing but P0 minus P. Difference between stagnation pressure and static pressure. Stagnation pressure and static pressure. So in case of incompressible fluid flow, P0 minus P is nothing but half rho V square. So Q incompressible can be written as half rho V square. So you keep it here. Okay, you keep it here. Now I am moving to compressible flow. So students, in compressible flow, in case of compressible flow, you have learned many equations relating T0 by T as some 1 minus 1 plus gamma minus 1 by 2 m square, right? Similarly, if you write P0 by P, you will get it as 1 plus gamma minus 1 by 2 max square into gamma by gamma minus 1. Okay? So this equation you know. So using this pressure equation, you can write Q compressible. Q compressible, P0 minus P is nothing but, if you take P0 outside, or you take P outside, you just take P outside, okay? P0 by P minus 1, right? So P into P0 by P is nothing but 1 plus gamma minus 1 by 2 max square gamma by gamma minus 1, right? Minus 1. So this is Q compressible, the Q compressible, dynamic pressure in case of compressible fluid flow, right? So students, now I am expanding this term. So in Max, you have studied the equation, the expansion of a series, expansion of series. 1 plus x raised to n can be written as 1 plus nx plus n into n minus 1 2 factorial into x square plus n into n minus 1 into n minus 2 into 3 by 3 factorial into x cube. Like this equation, this kind of series expansion you have learned in your max class, right? So I am applying this same thing in this. So 1 plus gamma minus 1 by 2 max square into gamma by gamma minus 1. Here I am taking x as gamma minus 1 by 2 max square and n as gamma by gamma minus 1. So similarly I am expanding this series. Which series? This particular series. In this series I am expanding, in this equation I am expanding this series. So what will happen? Q compressible can be written as P into, if I expand that bracket, it will become 1 plus gamma by gamma minus 1 into x. So this is n and x is gamma minus 1 by 2 max square. So first term is okay. Next term is n into n minus 1 by 2 factorial. So n is gamma by gamma minus 1. N minus 1 is gamma by gamma minus 1 minus 1 by 2 factorial is 2 into gamma minus 1 by 2 max square whole square, right? So similarly, the series continues, and at last 1 minus 1 is there, right? Which minus 1? So this minus 1 is there. So I'm adding this minus 1 also. So this 1 and this minus 1 cancels, and you will get Q compressible as some P into, if you expand you will get gamma m square by 2 plus gamma m raised to 4 by 8 plus some gamma 2 minus gamma, if you continue expansion you will get m raised to 6, and series continues. Okay, so students, you can note that the max square, in the first term it is max square, next is max raised to 4, next is max raised to 6, then max raised to 8 comes. So students, you can do one thing, you can take gamma and max square by 2, this term outside, and one p is also in outside. so outside the bracket. So what is remaining? 1 plus some m square by 4, and the series continues. So from every term you will get one gamma and one max square and one 2, and these things are common in every term. This term can be taken outside. So what is gamma pm square? Gamma pm square is nothing but gamma into p into v square by a square, right? So gamma p v square by gamma rt. A square is gamma rt. So gamma and gamma cancel. What is p by rt? Rho v square. Okay. So I can substitute gamma m square p as rho v square. So q0 is nothing but rho v square by 2 into some 1 plus m square by 4 plus some terms, right? But in case of incompressible fluid flow, it is nothing but half rho v square. So in case of incompressible flow, it was just rho v square by 2. So what is the difference between compressible fluid flow and incompressible fluid? What is the difference between dynamic pressure in case of compressible and incompressible? In case of compressible, an extra term comes. So these two equations reveals that the dynamic pressure for a compressible flow is greater than that for an incompressible flow, because here Mach number will be a positive value. So this whole term will be a positive value, right? Positive value greater than 1. Positive value greater than 1, right? So that value will be greater than 1. So anyway, Q compressible or the dynamic pressure in case of compressible will be greater than greater than the value in the case of incompressible flow. So the compressible flow dynamic pressure is greater than that for an incompressible flow by a factor which is a function of both the Mach number and the gamma specific ratio specific. So that is the difference between that is the effect of compressibility on dynamic pressure. Students, another important concept called compressibility factor, flow compressibility factor or pressure ratio pressure ratio is nothing but Cf equal to Q dynamic pressure in case of compressible by dynamic pressure in case of incompressible. So this is nothing but half rho v square into 1 plus Mach square by 4 plus 2 by gamma by 24 Mach raised to 4 etc. by 1 plus half rho v square. So this and this cancel. So Cf is nothing but 1 plus Mach square by 4 plus 2 by gamma by 24, 2 by gamma by 24 into Mach raised to 4 etc. Right. So for incompressible flow, what will be the value for incompressible flow? Cf will be 1. So this 1 and 1 cancel. It is in the flow compressibility factor for compressible flow is greater than unity by this much terms. So you don't worry, you just note down this value. Pressure ratio or compressibility factor is nothing but 1 plus m square by 4 plus 2 by gamma minus 1 by 2 by gamma 2 minus gamma by 24 into m raised to 4 plus etc. So with this I will stop this session. Thank you. I think I've completed all the topics in this first module, and we have to do some problems regarding these topics. I think it will be more comfortable if we do the problems in our online meeting session or Google Meet, so we can interact with each other, and it will be more useful than doing these problems by recording. and uploading to YouTube. So better we will meet in Google Meet in coming days and do some problems, and we will move to the next module. So hope you understood this module. Actually, this module deals with the basic concepts of compressible fluid flow. There are a lot of equations, so you don't try to by heart all these equations, but you can, whenever you require some equation, you can easily develop or derive those equations from the basics. So if you are thorough with the basics, you can develop any kind of equation easily. Suppose you are asked to find the relationship between S star and A0, means you don't have to by heart that equation. You just need to know the basic adiabatic equation. For that adiabatic steady flow adiabatic equation, from that equation you can readily extract or derive the required relations. So that is the method. So if you are asked to find the Krok number or relationship between Krok number and Mach, you just need to know what actually is Krok number. Krok number is nothing but V by V max. So V by V max can be written as V by A star in A star into A star by V max. So V by A star is max square. Max star. A star by V max is the relation you have to derive from a adiabatic equation. So this concept, if you know the concept and if you know the basics, you can easily, readily get any type of equation within fraction of seconds. Okay, so that's the idea. So thank you. If you have got any doubt, we can discuss in our Google Meet session. Thank you.